In the 1950s, the statistician Simon Broadbent had a stubborn engineering problem: gas masks for coal miners. Their stilters were beds of charcoal granules, riddled with microscopic pores. Some batches let the air through and worked. Others, same charcoal, same amount of pore space, were useless. The difference was not how much empty space the filter had, it was whether the empty spaces connected. With the mathematician John Hammersley, he turned that question into mathematics and found one of the sharpest edges in all of physics. Here is the whole model. Take a grid, open each site at random with probability p. That one number is the porosity. Water enters from the top and flows only between open sites that touch side by side, never diagonally. Then ask a single question: does the water come out the bottom? Yes or no. There is nothing in between. Everything you are about to see follows from those three rules, and from the number p. Start at 45%. Nearly half the rock is open, pore. The water dies 9 rows in. All that open space forms pockets, puddles sealed in stone, not paths. So open more of the rock. 55% deeper this time, 4 rows in 10, and stopped again. More than half of this rock is hollow, and it is still, for every practical purpose, waterproof. Now, do it slowly. Same rock, and we raise the porosity 1,000 at a time. 52%, sealed. 55, sealed. 57, 58. The water probes deeper, whole basins fill, and still, every attempt dies in the stone. 59, watch. 0.592, breakthrough. One more pore in 100, and the water runs top to bottom. Broadbent and Hammersley proved that an infinite version of this rock has an exact edge, and decades of computation have pinned it to 4 digits: 0.5927, not 60%. Maybe that rock was special. So take a bigger grid, 40,000 sites, and hold the porosity at 57%, just under the edge. A fresh rock, sealed. Another, sealed. Again, sealed, sealed, sealed. 5 random rocks, 5 verdicts, no exception. Now step over the edge to 63%. Breakthrough. Again, breakthrough. Every single rock in seconds. The randomness decides the details. Where the path snakes, how deep the dead ends go. It never decides the verdict. The verdict belongs to P. One trap remains. Color every connected pocket and look at the largest, the amber monster. At 57%, it already covers 18% of the entire rock. Surely that reaches the bottom. Pour the water. It rides the giant cluster 83 rows down, 83 out of 100, and stops. Below the threshold, clusters grow enormous. They are never infinite. Big is not the same as through, and that gap is exactly what the threshold measures. That is percolation. No forces, no temperature, nothing ever moves. Just a random grid and one number. And yet, it hides a true phase transition, the same mathematics that decides when a forest fire spreads, when an epidemic travels, when a powdered material starts to conduct. This was SimSciences. The rock is on the site. Pour it yourself and find the edge.